Yes. All right, so we got these definitions from the PowerPoint. A term for a polynomial, which is polynomial is a collection of many terms. That's all that means. Polynomial, many terms. A polynomial term can be written as a number or the product. What did we say the word product was? The word product means multiplication, right? Product of a number or one or more variables. So an example could be 5 would be a term, or 5x, because that's a number times a variable, or 5xyz. And by the way, it doesn't have to have 5 as the coefficient. It could be 15, right? The coefficient can be any number. That just tells us how many of those terms do we have. And then their whole number exponents. So this exponent is 1, and these exponents are 1. If you even had 17x squared, that's a whole number exponent. So you just can't have a negative exponent. You can have negative exponents, but you can't in a polynomial, right? And you wouldn't have fraction exponents right now. We will get to fraction exponents. That's going to be all the way in Math 95. Okay, and then terms are always separated by addition and subtraction. So if I write 5x plus 17x squared, that is actually counts as 2 terms, 2 separate terms, because they're separated by addition or subtraction. Now, if you want to be able to combine them, they have to be alike. So like terms have the exact same variables and corresponding exponents. So right here, even though these have the same variable x, because one of them is to the first power, the other one is to the second power, they don't count as being alike, right? You could say the x squared is like the big guy, and then the x, that's the little guy. So they can't combine, because what would you rename it if you were going to add them together? They're essentially, one is x, the other one is x squared. It's kind of like having a line and trying to add it to a square. See, here's x squared, here's x. They don't combine. They're not the same thing. Okay, so determine if the following are like terms. Is 5x and 7 like terms? No. What about 5x and 7y? Also no. Why not? Different variables. Is 5x and 7x squared alike? No. What about 5x and 7x? Yes. So that means, since these are alike, if I was going to add them, I could combine them into 12x's. How did I get 12x? Yeah, I simplified. Okay, and notice that like terms do not have to have the same coefficients. They can have different coefficients. Okay, let's look at this one. M squared n, and by the way, there's an implied 1 here. So there's just, it's kind of like you showed up to class, there was only one of you, right? Did you walk around with a 1 in front of you to let everyone know that there's only one? No, it was implied. Same thing with the m squared n. You only have one of them. I just put the 1 there as a little reminder that there's only one. Okay, and then here you have 5 of them. Are these alike? What makes them alike? Exactly. So if I have m squared n and I wanted to subtract 5m squared n, what would I get if I were to combine those two? I would have negative 4m squared n, right? The variables and the exponents stay the same. The coefficient tells me how many I have. If I subtracted 5 from 1, I would get negative 4. Yes. If the exponents wouldn't have, and that's the exact same thing that's going on in the next one. Look at this one. Are these ones like terms? The next one. And why would you say no? Exactly. Does that answer your question? The exponents are different because the m is squared and here the n is squared. What about these two? Are these alike? And that one's a little bit tricky because they don't look alike. And I will tell you that most often with a term, yes, we should list this one with within the term, we want to list it in order, in alphabetical order. So that way, it's more obvious that it is alike with the other one. Yes. Yes. Yes, so the x and the y, exactly, you're exactly right. This means 7 times x times y squared. Only the y is being squared. The 7 is not being squared, and the x is not being squared. And these would be alike, and if you put them in alphabetical order within the term, it makes it more obvious. You know what I mean? So I moved the y squared to the end, and then it becomes more obvious that it's a like term with the other one. Okay, now we move on to simplifying if they're alike. Okay, so here, oh my gosh, isn't that funny? I just did this exact same example. So what would be the first one, the answer to the first one? Do you notice what it would be? Yes, it'd be negative 4m squared n. See, this math teacher, whoever wrote this is Rhonda Hull, actually, probably. We think alike. We thought of the same exact problem. Okay, what about this one? Can we add these? And so if it's not possible, you can say not like terms. It's not possible, and that's the reason why you can't add them together. Now we rearranged this one to be 7xy squared plus 1/2 xy squared, and we identified the fact that they're alike. So what would you get if you added them together? Yeah, and you wanted to use a decimal before, so let's go ahead. If you want to use a decimal, that's fine too. 7.5 or 7 1/2 xy squared. Can anyone tell me what the improper fraction would be for 7 1/2? We go 7 times 2. Yes, 7 times 2 is 14 plus 1 is 15. 15 halves xy squared. These are all equivalent. And me personally, I would accept any one of those answers. I can't speak for, no, I care if you simplify. These are all simplified. Yes. You can, in my book, you can leave it as an improper fraction, as long as it's simplified. You see what I'm saying? Okay, it's not like 30/4 or something. Yeah, no, I don't want 1,500 200ths or something. Okay. Now, let's talk about the distributive property. Recall the distributive property. The distributive property looks like this. A times B plus C. It's like if I brought cupcakes for the class, which I will never do. I'm sorry, because I'm trying not to eat sugar, okay? But if I did, and I gave everyone a cupcake except for you, did I truly distribute? No. So the same thing happens here. A is going to distribute to B and C. So you get A times B plus A times C. That's just a bunch of variable letters showing that because I'm multiplying A times a number, I'm going to pass it out. Now, before I was talking about the fact that this is really the same thing as -1. If I want to distribute the negative sign, I'm going to distribute the -1 to both, right? They're both getting subtracted. So this becomes -m minus 24. Oops, and I wrote 25. I don't know why I did that. Does everybody see what I did there? I distributed it's called distributing the negative. Why does this become important? Because here, if I want to take 20 and I want to subtract all of this, that means I need to distribute the negative sign or distribute a -1. I get 20, oops, I'm putting equal signs, 20 minus m minus 24. Now, is there anything that can simplify, anything that can combine here? Because I want to subtract the whole thing. So I'm going to be subtracting 20. What are our like terms? Yes, 20 minus 24. What is 20 minus 24? -4, right? So we would have -m minus 4. Does everybody see where I'm getting that? -m minus 4? Okay, here, again, I'm going to distribute the negative. So I get 20m minus m minus 24. Now what are the like terms? The m's. So 20m minus an m, how many m's do you have left? 19m's minus 24. Can you subtract the 19m and the 24 from each other? No, because we don't know what m is, and the whole point is if I had a number for m, I could plug that in. I'd have to multiply it before I could subtract the 24. Okay. So let's keep going here. We're going to add these polynomials. So we want to add this expression, 6 minus 15x squared, to x squared plus 40. So we're going to write an addition problem. Let's look for our like terms. Now, something that could be very helpful, especially for those of you who are visual, you might underline the like terms, the x squareds, right? Or maybe you put a box around it. Here's a box, here's a box. If I have negative 15x squareds, that means I owe someone 15x squareds. And I'm going to add to that an x squared. How many x squareds do I have? Negative 14. Negative 14x squared. The other like terms are the 6 and the 40. Those are what we call constants. A constant is a number that has no variable. So what's 6 plus 40? 46. Good. Now here, this one is important. We have to subtract this from this. So does order matter with subtraction? Yes. So which one goes first? X squared plus 40, subtract. We want to subtract this whole thing. So that's why we put parentheses 6 minus 15x squared. Notice with the addition one, I could have also done parentheses here, you know. Why did I put parentheses around the thing? Because the polynomial, it's actually called a binomial. Okay, why did I put parentheses around it? Because I want to subtract the whole thing. When I subtract it, I have to add, I'm going to distribute. Add a negative 6. What's a negative times a negative here? Give me. Do you see how that negative, if I distribute the negative, because if I subtract a negative 15, it's the same thing as adding, right? Okay, so then what do we get here? What are our like terms? And again, maybe you take your colored pen and you kind of code. What are my like terms? Here's like terms. Here's like terms. Who can tell me what you get when you add, now when you simplify it? Since I distributed the negative, I'm going to add the like terms. 16x squared, good. Yeah, because you have 40, you owe 6, plus 34, okay?